test. Can you hear? I don't know. Hello? Did I miss something? What happened? Oh. Okay. This was not like this 2 seconds ago. So let me just readjust. Okay, pull that up. Okay, well, we'll play this game, see how it goes. All right, so we are working with similar figures, and we have been working with geometric mean. So we learned two different methods. The first one was actually the T method, which we'll see in the second problem, but this one is what we call the 7 method. And when we do this, what we're looking for is to draw some 7s with our problem. So what we are doing is we have the 90-degree angle and then what we call the base of our triangle. So this base we definitely need to use every single time. And in the 7 method, you have to travel the length of the court first. So that's where you see CD being first in the blue. Then we go down, D to B. Then we come back up, B to D. So that's why these two letters are inverted. So we did DB, and then we go BD. And then we finish off with just a little 7, and then we do DA. And what we're doing is we're making similar triangles with like the big triangle and then the little one inside of the big one. So that's why we set it up the way we do, and to make sure that everything's aligned is because we're doing similar triangles, but we're using the big one and then one of the ones inside. Hey, what's going on?
Hi.
You going to bed?
Yep.
Okay.
Love you too. Night.
Night. All right. So with this, we're doing the 7 problem. So what we need to know is, first off, we need to highlight the sides that are given to us. So that's one of the sides that's given to us. And then this is the other side that's given to us. So how do we know which one is the 7, like the base of the 7? And one of the things with the 7 method is we have to start at the bottom of the 7. So this is what I told my students. First off, you have to find the 90-degree angle. This is our base side. So the base side is our big, long piece of the 7. Okay? And with that being said, the 7 has to connect with the top piece. So what one connects with the top piece? So that means this is our top part of the 7, which means A has to be our bottom piece of the 7. And this is where we must start with the 7 method. Okay? So when we do this, we want to write a similarity statement. And the first thing we have to do is run the length of the court. So we're going to go A all the way to C. And that's going to run the length of the court. Then we're going to take this and run down the 7. So we're going to go C to Q. And then we are going to come back Q back to C. And then lastly, we're just going to take a little jaunt to the middle of our range, and we're going to do CB. And that becomes our similarity statement. And if you've been watching the videos before, we always want to set up a similarity statement, then we're going to substitute our numbers in, and then cross multiply and solve has been our go-to. So hopefully we can keep that going. So AC, so the whole width of the thing, A to C, they tell us right here is 12. And then we run down C to Q, which is 5. And then we run back Q to C. And what I told my students is, if I'm looking at home or work, the distance from home to work and work to home is the same length. It's either I'm going to go home from work or I'm going to go to work from home. So that distance doesn't change. It's just, am I traveling from home to work or work to home? So when we look at CQ and QC, that's how I apply that information or that analogy, because yeah, it says CQ and then it says QC, but really we're just talking about where we started from to where we finish. And then lastly, this little jaunt right here, C to B, we don't know. So I'm going to leave it as CB for right now. And we'll call this substitution. All right, now our ever famous cross multiplication. So we want to cross multiply. I'm going to move it over here and I'm going to do 12 times CB equals 5 times 5. And call that cross multiply. After that, we want to simplify it. So 12CB just becomes 12CB, but 5 times 5 we can change to 25. And then our last step, we want to solve for that CB, so we need to get rid of our number 12. So in order to do so, we want to divide both sides by that 12. Reason being, we want to get CB by itself. And then when we do that, we're going to get 25 over 12, and we got that by division, property of equality. 25 over 12, I have no idea. So take our handy dandy notebook, 25 over 12, hey, our Desmos, and we're going to get 2.1. So realistically speaking, this is 2.1. However, does that make sense to us? Do you understand that the distance from C to B is 2.1? And if you do, great. If you don't, that's what it stands for. It stands for this distance in between C and B. So if the question was asking you what is the distance from A to B, you actually can't answer that straightforward. You have to figure out what C to B is first. And because we know 12 is the distance from A to C, so we would do AC, and we would do the segment addition postulate. So we want to do a piece plus a piece equals the whole thing. We know AC is 12, AB is X, and BC we just found to be 2.1. So we would subtract 2.1 from both sides. We would get X, because this would zero out, and we would get 9.9. as our solution. So depending on whether we needed C to B or A to B, one of those would give us that solution. All right. Next up. This is the other method we talked about, and this is the T method. So the T method, we can start at either end of the T. So in this case, we could start at either side of this T. And hopefully you can see the upside down T that is made. But when we run this, we run it from one of the tips of the triangle. And we're going to go into the mid. So we're going to go C to D. Then we're going to travel up D to A. Then we're going to travel back down A to D. And then finish it off to the other tip, D to B. And that creates our similar triangles. It's the two inside triangles that are similar to each other instead of the big one and a small one. But when we compare this side, it actually gets compared to that side. And then when you compare the green side, it actually gets compared to the blue side. So it's a little, it's just a little deceiving. But if you remember the T method, you don't even have to worry about which triangle is similar to which triangle. So when we do the T method, we want to run a tip, mid, mid to up to mid, and then mid to the other tip. So when we do this, first off, we have to find our base. So looking at this 90-degree angle, and the line that cuts through, this becomes our base. Okay? Then the other piece of given information is this. So this is why we use the t. If the number would have been outside, we would draw a line here and use the 7 method. So it just depends on what the given information is, on whether we use the t method or we use the 7 method. But because the middle piece is the one with the given or the unknown, could be a variable here, that's when we use the t. If it's outside on one of the other two outside sides of the triangle, that's when you have to use the 7 method. So that's how you kind of differentiate between the two as well. All right, so either way, in class I started from this side, so I'm going to start from this direction this time. And we're going to run P into B. Then we're going to go B up through H. Then we're going to run it back down, H down to B. And then we're going to finish off B to W. And this is our similarity statement for this problem. Okay, so now substitute our values in. So we know P to B is 15. H, B to H, and H to B, these are both going to be 8ths. And then B to W, they did give us a variable, so we're going to stick this in instead of using BW. And we can call all this substitution, because all we did is substitute values in for what our lengths were. Now, cross multiplication, cross multiply. So when we cross multiply, we want to do this on one of them, this on the other, and then set them equal to each other. So we're going to do 15 times n, and then 8 times 8. And I make these dots really big. I've said this before, but I don't want them confused with decimals, especially when we use decimals. Like knowing this is multiplication and then 0.1, you would know that's a decimal. So I really accentuate the multiplications. Just makes it easier to clarify what we're actually doing. All right, so I need to change this color. Let's go here and here. Okay, so I'm going to do 15 times n, and that's going to be 15n. 8 times 8, that's going to get me 64, and I can call this simplify. Now, we've got to get rid of the 15, so we're going to divide both sides by 15. Because we want the 15s to one each other out, cancel out. And what I'm going to be left with is n, which is kind of my goal anyways. I want to get n by itself. And that's going to leave me with 64 over 15. And we use the division property of equality. So n is going to equal 64 over 15. And we used division property of equality. I just know the green's difficult to look at. So then let's do 64 over 15 and get 4.3. So then they tell us that this is 4.3. Now, if they ask for the total distance between P and W, you're not done. Then I would have to do 15 plus 4.3 to equal 19.3. So be careful. Make sure you answer what the question's asking you to do. But if it was just asking for n, solve for n, then we're done at 4.3. So we have two different methods. The first method that we started with was the 7 method, where we draw our 7s. Okay. And actually we start over here 7 down and then 7 back. Or we started down here 7 up and then 7 little. And then we moved on to our T method, which start either point, but we're going to go mid, up, down, back to the other tip. So we start at tip, go to mid, up, down, back to the other tip. That's our T method. Hope this helps. I got the first two done for you. You still have 2 other problems to deal with, though, and I want you to practice those on your own. Make sure you can do them. But take a look and look at what we're doing. Oh, I didn't put any geometric means. Well, anyways, I'm just realizing, like, I did an example of geometric mean and then gave you the triangles, but never actually did a geometric mean problem. But they'll get it through these two problems to do the geometric mean. I just wish I would have put, like, find the geometric mean between 8 and 5 or 7 and 2. Anyways, I hope that helps everyone. Once again, if you need math help, reach out. Reach out TikTok, whatever you need, Discord. I want to make math easy and fun for you, and hopefully you understand. So, with further ado, I'm going to end this session. Everyone have a blessed night. Have a great week, starting off Monday right, and make sure you start off Monday right. How you set the tone for the week is how your week's going to go. So, have a wonderful week, and we'll catch you next time.